Part 3 of laser and fiber optics, and we're doing a derivation in this video, which is expression for energy density using Einstein's coefficients. Let's quickly start. E1 is energy level, low energy level. E2 is high energy level. N1 is number of atoms present in E1, and N2 is number of atoms present in E2. U nu. U nu is energy density with frequency nu. Okay, this is all the things you have to know. So let's quickly begin. First is induced absorption. Okay, so this we have already seen in the previous videos. It's going from energy level E1 to energy level E2. Okay, and here energy is provided. Energy U nu is energy is provided. Here we have to know that rate of absorption or induced absorption is directly proportional to. First, let me write directly proportional to. Is directly proportional to. If more energy is provided, then more absorption. Right, more electrons will go up, and also more number of N1 should be there. Fine. So to remove this, I will write rate of absorption is equals to B12. From 1 to 2 it's going U nu N1. This is Einstein's coefficient, right, of induced absorption. Similarly, next we'll go for spontaneous emission. In spontaneous emission, it is coming no, the particle is coming from E2 to E1. Here N2, here N1, and here we know that particles come from here to here. From here to here. Here we know that no energy is supplied here. So here, if I write rate of emission will be directly proportional to N2. If there's more number of particles up, more number of particles will get emitted. Correct. So here, to remove the proportionality, rate of emission is equals to A21 into A21 into. Here A21 is the in Einstein's coefficient of spontaneous emission. Spontaneous emission. Next, coming to stimulated emission. Here also we know it is coming from E2 to E1, and this is N2 and this is N1. But here we are providing it with energy, which is U nu, and photons are released. That is not required here. Photons released we know, but for this derivation currently it is not required. Okay, N2 and this is N1. Here rate of stimulated emission is directly proportional to one, obviously U nu, and one more is N2. More energy, then more emission, then more N2 also more emission. So to remove the proportionality, rate of stimulated emission is equals to B21 U nu N2. Okay, here first one is B12. Here it is B21. Okay, don't get confused. This is Einstein's coefficient of stimulated emission. Fine. Next, what you remember is that at thermal equilibrium, means what, temperature is constant. Here rate of induced absorption is equals to rate of spontaneous emission plus rate of, if this equation you remember what I'm writing now, half the work is done. Rate of stimulated emission. At thermal equilibrium only, the rate of induced absorption, how much is absorbed, that much is emitted. At thermal equilibrium, means temperature is constant. Fine. So that only we will write in terms of this. Rate of induced absorption was written as B12 N1 U nu equals rate of spontaneous emission was written as A21 N1 plus this rate of stimulated emission was written as B21 N2. Yeah, this is N2, right? Yes, it's N2 U nu. Now I'm keeping U nu this side, or I just first I will make U nu this side. I will make it common, right? Fine. Sorry, B12 N1 U nu minus B21 N2 U nu equals A21 N2. Now I'll take U nu common, and B12 N1 minus B21 N2 equals A21 N2. U nu will be this side, and this I will take in the denominator. A21 N2 by B12 N1 minus B21 N2. Now my next is divide each term. What am I doing? I'm going to divide each in RHS by B21 N2. This is also something which you remember. There's like small things to remember. The derivation is super easy. Rest all is just math. So U nu equals A21 N2 by B21 N2, which is divided by, for now I'll write this so I can see and write. See and from the above, right? B12 N1 by B21 N2 minus B21 N2 by B21 N2. Your N2 N2 gets cancelled. So A21 by B21 divided by B12 N1 by B21 N2 minus 1. Okay, this is U nu. right? So u nu equals, I'm just rewriting it. Okay, a21 by b21 divided by, right? So divided by, I can also write as into. This whole thing is basically like this denominator. So I will write it as, now I'm multiplying. Now I will take like reciprocal. 1 by, I hope you got this thing, what I'm doing. B12 in 1 by B21. Why am I doing this? Because instead of division, multiplication I'm taken. B21 into minus 1. Fine. There, and then there is one Boltzmann theorem. This is not part of the derivation. This is part of the derivation, but not like you've derived from somewhere. Boltzmann theorem, it's there one, which we're using here, which is u nu equals e power h nu by kt. E power h nu by kt. Okay. So this u nu, sorry, I'm so sorry. One small mistake has happened. This is not u nu. This is n1 by n2. n1 by n2 is equals to e power this one. And here, where is n1 by n2? Here, n1 by n2 is here. So that we will write here. Okay, it's fine. Let's write here only, fine. So u nu equals a21 by b21 into 1 by b12 by b21 remains the same. b12 by b21, n1 by n2 is will be converted to e power h nu by kt minus 1. Then one more. Now this comes using Planck's law, and Planck's law also is there, which states u nu equals 8 pi h nu cube by c cube into 1 by e power h nu by kt minus 1. Now you have to compare this and this. A21 by B21 is same as this, and 1 is the same as 1. B12 by B21, there's nothing. So that is equals to 1. And then minus 1 same. E power h nu by kt means the same. So A21 by B21 equals 8 pi h nu cube by c cube. Then B12 by B21 equals 1. Okay, so now what I'm trying to say is here B12 will be equal to B21. So what does that mean? Rate of induced absorption is equals to rate of stimulated emission. So there is no role of spontaneous emission at all. So how much ever is absorbed, that much all goes in stimulated emission. So how is this good? It's because now the electron is going from E1, the electron which is going from E1 to E2 is all of that is participated in, after while it's coming back, is all of this participated in stimulated emission, not spontaneous. Because if even if it's even if it is participating in spontaneous, let's say if you is participating in spontaneous, okay, then the output decreases, because for every part come from E2 to E1, every part comes from E2 to E1, two photons are getting released. So if if it's going out by spontaneous, then the output will decrease. So no spontaneous emission, all are participating in stimulated. Even by our calculation, that only is shown. So efficiency of laser light is high, intensity is high. Even if, like, let's say two of them are somehow not in control and they participate in spontaneous emission, output decreases. Even if two of them goes, the output decreases by 4 photons, right? So stimulation emission is better than spontaneous emission. And to rewrite that formula, I can write u nu equals A21 by B21 1 by, here it was b12 by b21, which is 1. So basically e power h nu by kt minus 1. You can rewrite the formula like this, and that's the end of our derivation. Thank you.